Hey folks, graphing rational functions. This is a continuation of last time's notes. This is where we already broke down how to find all these pieces. What we're going to do today is we're going to take these pieces and add them to the graph. Now you might notice we have a new characteristic called SA. Don't worry too much about that. That's a slant asymptote, and I'll do the best I can to explain that. It's a pretty minor detail. It's mostly for our AP kids. So you should be able to fill out this chart. If you haven't yet, you can add that list to the parent function sheet, but you should be able to write down, you should know how to find all these things, or at least be able to look them up on your parent function sheet. So I'm going to encourage you to, we'll do this one together. Let's just do a quick review. HA. I find the HA by comparing the leading coefficients, leading terms. So 2x squared over x squared, more x's on the top, bottom, or tie. This is a tie, which means it goes to the coefficients. So that means it's 2 divided by 1. 2 divided by 1 is 2, but don't forget the y equals. Now, if you have an HA, you do not have an SA. That's called a slant asymptote. So most of our examples, actually until the very end, the SA is going to be none every time. So let's not sweat what the SA is until we get to one where we have to use it. So let's leave a little note here. Note, one of these will always be none. So in other words, if the HA is none, then we have to worry about an SA. If you find the HA, then you don't have to worry about finding the SA. All right, VAs, these are things on the bottom that don't cancel. So I got to first figure out how to factor this. So this is going to be 2x and x. That's 4, that makes 3. So that's going to be positive 2 and negative 1. This is going to be x. So 6, that makes a negative 3 plus 2. Anything cancel? Yepper. Okay. Thing in the denominator that doesn't cancel, x minus 3, ZPP it, so we get a VA of x equals 3. Our whole, we do have something that cancels, so that's when x equals negative 2. I got a ZPP, what canceled? The 0, anything in the numerator that doesn't cancel, ZPP, 1/2. Y-intercept, compare your constants or plug in 0 for x, so that's gone, negative 2. 0, 0, negative 6. Negative 2 divided by negative 6 is 1/3. All right, so that little chart that we filled out, this should be a continuation of what we did last time. Let's start off by drawing the VAs and the HA. Those are the easiest thing to identify. Your HA is the equation y equals 2. So I want to go to the y-axis. I want to go to 2. That becomes my horizontal asymptote. My vertical asymptote, I go to x, I go to 3. That becomes my vertical asymptote. Now, there's a couple of things to think about at this spot. We know that our function is a rational function. So if you go back to our notes, every one of these are going to be rationals. They're going to look exactly like the reciprocal function from our transformation of the parent functions last unit. So one branch is going to be here, the other branch is going to be there, or one branch is going to be here and one branch is going to be there. So they're always going to be kitty corner. They do get more complicated, but that's not something we're going to worry about this year. So what I recommend is start to identify the points. So we know that we have these 2 points. Now, these are not shifted points. These are actual points. So let me leave a little note here. These are real points. No shifting. And what I mean by that, remember when we did the shift and transformations of functions, and then this became the new 0, 0? That's not the case in this. This is not the shifting. We found the shifts based on the HA and the VA. All these points are not dependent on the shift. They're independent of that. So the actual 0 is at 1/2 0. I'm going to make a little dot there at 1/2 0. My y-intercept is at 0, 1/3. So this is not going to be the world's greatest picture. Maybe I can zoom in a little bit to try to see it a little better. 0, 1/3. That's enough. That's close enough because now I know where all the pieces are going to fall. I know that one branch is going to be here, and then the other branch is going to be up here, kitty corner. But don't forget, you still have to draw the hole. You don't actually draw the hole until you can figure out where the branches are going. So you're going to start to draw the branch asymptotic, and then when you get above x equals -2, stop and draw your hole. So I'm an asymptote. I'm tracking in, I'm tracking in, I'm tracking in. Now I'm right above -2. I don't care what height it is. It's wherever my graph happens to be. I'm going to stop, and I'm going to draw the hole there. Then I'm going to continue, hit the 2 points that I have, and then go asymptotic the other way. I actually like to draw a little arrow to remind myself that there was a hole. Now the other branch is going to be over here. It's going to be asymptotic, and it's going to be trapped in that section. So how curvy are you supposed to make it? I don't care. I don't care. As long as you have the hole at the right X value, your height, maybe you drew yours a lot closer than I did. Maybe you drew yours a little less close. That's fine. As long as it's appropriately placed based on what you called or what you thought the curviness of the function was. I'll call that good. All right, so let's throw you to the wolves here. Let's have you try to pause this, try to do 1 part B. All right, let's see how you did. So I'm going to start off by trying to analyze. HA, more x's on the top, bottom, or tie? It's a tie, so y equals the coefficient 1/2. 2/4 is 1/2. If I have an HA, that means I do not have an SA. VA, things on the bottom that don't cancel. That means I need to factor this. So this is going to factor into 2x and x. 6, that makes -5, so that's going to be a -6 plus 1. This is dopes on the bottom, so that's 2x plus 1, 2x minus 1. I'm trying to identify if anything cancels, and I see pretty quickly that stuff does cancel. So 2x plus 1, 2x minus 1 cancel each other out. My VAs, things on the bottom that don't cancel, so x equals 1/2. Holes are when things cancel, so x equals -1/2. Zeros, numerator, no cancel, so that's 3, 0. Y-intercepts are when you plug in 0 for x, so that would be gone, gone, -3, gone, -1. -3 divided by -1 is +3. Okay, we've got this thing all figured out in terms of the characteristics. Now we just need to plot them on our picture. So HA of y equals 1/2. So this is going to be not a great, I got to kind of estimate the height of 1/2. That's not the best thing in the world. Then I've got an x value of x equals 1/2. So that's looking something like this. There we go there. Yeah, close enough. It's not gonna, it doesn't have to be perfect. It has to just be decent. I'm more interested in where you draw your intercepts and your holes. So I have a intercept at 3, 0, so 1, 2, 3. I have a y-intercept at 1, 2, 3. Okay, so this time is really easy. I have a point in each quadrant, so I'll be able to tell right away that I've got a branch down here and I got a branch up here. But before I start drawing, I've got to remember when I get wherever my graph is, above x equals -1/2, I'm going to stop and draw a hole. So asymptotic, draw, 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 draw. Oop, there's x equals -1/2. So there's going to be a hole here. Hit, launch off to infinity. I like to draw myself a little note. that I did identify where the hole was. The other graph is going to be asymptotic here, hits that x-intercept, and then goes asymptotic this way. So I think we've got the idea. This one is almost exactly like, let me zoom out. So part C is almost exactly like part B. You can do it. I'll show my work on it at the end if you want to come back and try that one again, or you can just go right to the homework. I think I left this just as an extra example if needed. So let's go to this one. I'm going to do this because I think I can go a little bit faster and we can get to where we need to be. So let's start off. HA. Do I have more X's on the bottom, top, or tie? More X's on the bottom. So if there's more X's on the bottom, that means the graph levels off. So I'm going to have more X's on the bottom. That means the graph levels off at 0. I think about it as there's more X's on the bottom, then my graph is getting pulled down to nothing. Now, if you have an HA, even if it's X or Y equals 0, you do not have an SA. That's automatically none. VAs, I got to figure out what cancels. So this, both divisible by 3. So that's leaving 2x minus 3. 6, 18, that makes 11. That's 2 and 9. So I'm going to have a 3x and a 2x. I need to make a negative 9 and a negative 2. So we do have things that cancel. Cancel, cancel. So I can now fill in the rest of my chart. VA, things in the denominator that don't cancel. ZPP this, so 1/3. Yuck, why do I pick these crappy numbers? When X equals whole is when it does cancel, so that would be 3/2, so that's at 1.5. Zeros, things in the numerator that don't cancel. Now this doesn't cancel in the numerator, but it doesn't have an X, which means we can't solve it. It doesn't have a solution. You ZPP this, it'll just say 3 equals 0. Well, 3 doesn't equal 0, so there is no 0, so that's interesting. And then our y-intercept is when we put a 0 in for x. So when I put a 0 in for x, I get a negative 9. 0 gone, 0 gone, so negative 9 divided by 3 is negative 3. All right, let's sketch it. HA, y equals 0. This is always kind of a pain. Just do the best you can. Try to like highlight either above or below that line. Oh, I wish I wouldn't have done that one. Yuck. Anyway, my x is 1/3. Try to do the best you can. I'm going to estimate that was 1/3. And then I have a hole at 1.5. So when I get there, I want to stop and draw it. I don't have any zeros, and I do have a y-intercept of 0, -3. 1, 2, -3. Now that's enough info to get my graph going. That means I've got one here, and then my other one's going to be kitty corner. So when I'm drawing x equals 3/2, that's going to be for this part. So I can draw this one, continuous. Now as I draw this one, when I get to 1.5, so that's going to be above here, wherever my graph happens to be. Some kids try to draw it at a certain height. You don't, you just let the graph draw itself. This is a hole. Maybe I should write a little note about that 3 equals 0 thing. Can't solve that. That's why that's not a 0. Okay, I'm going to encourage you to pause here and just fill out the table. Don't actually sketch it. Just fill out the table. All right, let's see how you did. HA, compare. 1x on the top, 1x on the bottom, so it becomes y equals 1. That means the SA would be none. Vertical asymptotes, things in the denominator that don't cancel. Well, x minus 1 doesn't cancel, so when I ZPP it, I get x equals 1. Whole, things that cancel. Kind of nice. This one doesn't cancel. Nothing cancels, so there isn't a hole. 0, things in the numerator that don't cancel, so when I ZPP that, I get -2. Y-intercept, put a 0 in for x. So that would become 2 over -1, which is also -2. I'll sketch it just for the heck of it. This is pretty easy to sketch. Y equals 1. X equals 1. 0 is at -2, 0. Y-intercept 0, -2. That means this branch is down here. It's kind of nice. I don't have to overthink it because my hole doesn't exist. There is no hole. Here's my picture. And then last but not least, we're going to do an example where the SA does exist. And like I said, this is going to be one more for my advanced students. So HA, compare numerator to denominator. Do we have more X's on the top, bottom, or tie? Well, clearly we have more X's on the top. So when there's more X's on the top, the graph floats off to infinity. So that does not level. Okay, so then how do I find the SA? Well, remember, this is still a division problem. So to find the SA, you want to go down and do some synthetic division. So I'm going to take my numerator, and I can do, I guess I can't say it's automatically going to be synthetic, but I'm going to set it up so everything's synthetic. But my coefficient is 1. My degree is 1, so I can do this synthetically, but I got to still ZPP this. So I ZPP this, and so I get 1. My coefficients are 2, -1, and -6. Draw a line, the 2 drops. That's 2, that's 1, that's 1, that's -5. So then this turns out to be 2. This was an x squared. We broke it down once, so that becomes 2x plus 1 minus, this is my, or plus, I always like to do plus. That's my remainder over my divisor. So this goes back to our synthetic division stuff. -5 over x minus 1. Now, why is that important? Well, that's because we want to think about this in terms of going towards infinity. So if I take this term and I take a look at it as x goes towards infinity. So as x goes towards infinity here, if x is basically infinity, what's infinity minus 1? Well, it's still infinity. And I would end up with -5 over infinity, which tends towards 0, which means this whole piece basically disappears. So this section disappears, which leaves me with 2x plus 1. That 2x plus 1 is my SA. So just like we did HAs were always y equals, our SA is x equals, the remainder goes off to 0, as x goes off to infinity, so we're left with 2x plus 1. So that's how you find an SA. Just synthetic divide and ignore the remainder, basically. VA, things on the bottom that don't cancel. I don't know if anything cancels until I factor it, so I got to just factor the numerator this time. 2x and x. 12, that's 4 and 3. Oh, nothing cancels. That's kind of nice. So I don't have any holes. Anything in the denominator that doesn't cancel is x minus 1. When I ZPP that, I get x equals 1. I have 2 things in the numerator that don't cancel, which means I'm going to have 2 zeros. So at -3/2, 0, and then 2, 0. And then y-intercept is when x equals 0, 0, 0, -6, 0, -1, 6, -6 divided by -1 is 6. All right, let's make it happen, Captain. So instead of drawing an HA, I'm going to draw an SA, a slant asymptote. So we're going to just graph this line that's given to us in slope-intercept form. I've got a y-intercept of 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1. And that is my slanty asymptote. My VA is still x equals 1, so that's not anything new. And let's try to identify our points. So we have a 0 at negative 1.5, negative 1.50, and at 1, 2, 0. And we have a y-intercept at 0, 1, 2, 3, 4, 5, 6. So just like we did here, where the branches are always kitty corner, it's the same thing here, except our branches are not nice and don't meet at a nice 90 degree angle. So I'm going to go asymptotic just like we did before, but it's going to be sort of like stretched out. Okay, if you think you got it, you can go to the homework. I'm going to go and do this last example because I said I would for people who wanted to practice a little bit more. What would be a good color? How about a nice, we did blue, we did green, we did yellow. We did a couple other ones. How about a brown right next to a yellow? Man, oh man, it's a tough call. Yeah, shoot. How about a gray? I don't want to do gray. I guess I'll do a brown right next to a yellow. I have to live with it. No, we didn't do bright orange. How about bright orange? That look better than whatever. All right, HA, compare. X squared over x squared. It's a tie. If we have that, that means we don't have one of these. I have to factor to find this. 15, 30, that makes 11 is 6 and 5. So 2x and x. I need a 6. That's negative, and a 5, that's negative, right? Yeah. Okay, 2, 18, that makes 9 is 6 and 3. That's 2x and x. I need to make a 6, so that would be minus 6 and a minus 3. Do we have anything that cancels? Yes, we do. X minus 3 is gone. I probably should have used purple. All right, VA. Anything on the bottom that doesn't cancel? Yes. X equals 3/2. Does anything cancel? Yes. So we have a hole when x equals 3. Do we have any zeros? Numerator that doesn't cancel? Yes. 5/2, 0. Y-intercept, 0, 0. Put in 0 for x. 0, 0, 15, 0, 0, 9. 15 over 9 divided by 3. 5 over 3, 5/3. All right. Asymptotes, y equals 1. X equals 1.5. The points, 2.5 is 2.5. 1, 2.5. Y-intercept that's 1 2/3. So 1 2/3 would be, I don't know, something like that. And I do have a hole when x equals 3, so that's going to be on this branch. So I can start off this branch, asymptotic, hit the point, asymptotic, asymptotic, hit the point. And then, like I said, whenever you're drawing, wherever you hit above that number, that's where you draw your asymptote. So my graph was going in right here. I got above x equals 1, 2, 3. So wherever that was is where I draw my asymptote. All right, folks, good luck. Go get them.